Well, Monday is here again, and we got another little ASE practice test on engine performance. A little bit of study. I know some people are using some of my videos to study for ASE exams, and I get good feedback on that. I'm really glad to be helping some folks. And of course, there's a lot of good ASE study guides out there and that kind of thing. But usually when you take an ASE test, one of the things you have to figure out is how these people think and what kind of answer it is they want. If you occasionally, some of the newer stuff that it comes out with on light vehicle diesel, which I've got certification in that, they'll ask you some questions that'll throw you for a loop. And sometimes on manual transmission, they may throw you a question on some of these automatic shifting manual transmissions, you know, that is kind of tricky. But let's just get into this one here, and we'll talk along the way. Question 1, the washer around the base of the plug. You've seen this question before on some of my other tests, but I like to ask it. Is there for the primary purpose of what? Preventing compression loss, conducting heat out of the spark plug, placing the spark plug fire electrode at the proper depth, or keeping moisture out of the cylinder. That's question number 1. And I'll have the answers at the end, so stay tuned for that. Here's question number 2. On a negative coefficient thermistor, resistance does what as temperature does what? And you got decreases and increases, increases and decreases, multiplies or subtracts, retracts or expands. That's something really that everybody needs to know if you're dealing with electronic engine controls and stuff like that. Question 3, which sensor or circuit is not checked continuously on an OBD2 system? TP sensor, MAP sensor, ECT sensor, or O2 sensor heaters? We got like 25 questions here, so buckle down. Conventional oxygen sensors don't work until what? They reach 600, the system's in closed loop, the torque converter's locked, or engine coolant temperature reaches 200 degrees. Alright. Question 5. Which of the following would not be considered a computer input? Throttle position sensor, magnetic pulse generator, park neutral switch, or EGR vent solenoid? Alright, question 6. All engines have some kind of what system? PCV, EGR, AIR, or heated hydrocarbon vent? Let's move on to question 7. A lot of you have seen this chart here. A lean air fuel mixture burns A, cold and fast, B, hot and fast, C, hot and slow, or D, cold and slow? Alright, let's move on to question 8. The fuel pump on a vehicle can be heard for 2 seconds at key on, but the engine won't start. The fuel gauge shows a full tank. Fuel pump current draw is 8.9 amps. Which of the following is the least likely to be the cause? Empty fuel tank, water in the fuel tank, inoperative fuel injectors, or fuel-fouled spark plugs? Alright, let's move on here. If the idle air control counts are 0, A, the engine's running rich, B, the engine may have a vacuum leak, C, throttle plates may need to be cleaned, or both B and C are correct. Alright, question 10. The engine's running at 243 degrees, the cooling system's full of clean coolant, the air conditioner's off, but the fans cycled on at the proper engine coolant temperature, but they never cycle off. Both heater hoses are cool to the touch. Of the following, which is the most likely to be the problem? Stuck thermostat, bad water pump, too much heat transfer from the radiator to the ambient air, or too much hot gas EGR flow? Alright, Technician A says, and I've tried to keep these Technician A and B questions to a minimum on this test because I know how bad you hate them because that's like 2 questions in one. Technician A says the output of a Hall effect sensor can be checked with an AC voltmeter. Technician B says the output of a variable reluctance sensor can be tested with a lab scope. Who is correct? A only, B only, both A and B, neither A or B. Alright, what was the one thing OBD1 regulations required after 1988 that was not previously required? Now this is OBD1, this is not OBD2, it's OBD1, it's the first system. A, misfire monitor. 2, oxygen sensor. 3, dash mounted warning light. D, a dash mounted connector. Alright, question 13. EGR system failure can cause A, higher cylinder combustion temperatures, B, pinging and detonation, C, higher NOx emissions, or D, Any of the above. A technician has been led by a diagnostic trouble coach to investigate fuel trim numbers that are as follows. Short fuel trim, 1%. Actually, I got this as 0.01 on that little illustration. Long fuel trim, minus 25. A, the fuel filter may be restricted. B, the crankcase oil may be contaminated with fuel. C, the fuel pressure may be low. Or D, any of the above. And technician A says a bad radiator pressure cap can cause rust and corrosion buildup in a car's cooling system. Technician B says the large pipe on a heater core is generally the heater core's inlet pipe. So call it again. Who's right? A, B, both, or neither? Question 16. Identify the place on this cylinder pressure waveform where the exhaust valve is completely open. It'll be one of these. A, B, C, D, E, F, G, H. Alright. What's the most likely reason for a no start based on these PIDs? A, faulty baro sensor. B, a weak throttle position sensor. C, an open IET sensor circuit. D, none of the above. He needs to check more PIDs. A 5-cylinder engine has a firing event every how many degrees? 5-cylinder engine has a firing event every how many degrees? The temperature stamped on the copper case of a thermostat's wax pellet is the temperature at which the thermostat does what? Is it fully open, starts to open, fully closed, or is modulating? Technician A says exhaust gas recirculation is used to reburn some of the exhaust gas. Technician B says the EGR cools the combustion chamber to prevent NOx. Who's correct about that? A, B, both, or neither? Identify the point on this cylinder pressure waveform that most closely corresponds with valve overlap. A, B, C, D, E, F, G, H. Which one of these? If the vehicle speed signal is suddenly lost at road speed, what generally happens? A, the speedometer needle drops to 0. B, the speed control suddenly becomes dysfunctional. C, the transmission drops back to first gear. Or D, all of the above. Question 23. With the brakes locked and the engine in drive and accelerated to wide open throttle, what information might be gleaned from watching the stall speed on the tachometer? A, proper park brake function under load. B, the top boiling point of engine oil. C, integrity of the stator one-way clutch. Or D, nothing. This is dangerous and wrong. Question 24. A vehicle is traveling down a straight highway with the short and long fuel trims hovering near 0. What will initially happen to the O2 sensor signal on that bank if a spark plug suddenly begins to misfire? A, O2 will read rich, fuel trim goes negative. B, O2 will read lean, fuel trim goes positive. C, O2 signal will exceed 6 volts. D, O2 signal will switch normally. And finally, here's the last question, and then we'll grade it. If you switch on the ignition and hear the fuel pump, you know what? You know the PCM's awake and functioning, you know the spark plugs are fouled, you know the injectors are clogged, or that there is at least fuel in the tank. Now, swap papers with somebody and let's grade this. The washer around the base of some of the plugs, and like I say, if you've watched very many of my tests, you've seen this question before. Conducting heat out of the spark plug. Now you got to look at the wording here. Primary purpose. It's the primary purpose. On the ones that don't have a washer, the bevel seat, it needs to make contact with the head nice and securely. Means it's got to be tightened all the way down so that the heat can be conducted out of the plug. Anything that's exposed to that combustion chamber heat is going to have a lot of punishment to put up with. That's one of the reasons that gasoline direct injection injectors have got a long snout that goes down through a cooling passage. Basically, they're not in the coolant, but they're actually going through a passage that's, where they're cooled by the flow of the coolant. And they got a Teflon seal that's not supposed to be lubricated when you put the injector in there, because you don't want a seal that's going to let combustion get back up past that injector, because that can destroy the cylinder head, cause all kinds of grief. But anyway, conducting the heat out of the spark plug is really important because it gets really hot in there. When that burn is taking place, it's going to be over 2,000 degrees during the burn. Now that's going to raise your coolant temperature up a little over 200, but the actual burn is really, really hot. On a negative coefficient, negative, well, I meant to say negative temperature coefficient thermistor, I typed that wrong. Resistance actually decreases as temperature increases. Now, if you know a lot about, you know, the standard fare for just about anything that carries juice is the more the hotter it gets, the more resistance it has. That's true with a light bulb. You can take, if you know how to do calculations, you know, using your EIR formula, you can take those, a light bulb, and you can measure the resistance of the light bulb, the little tail light bulb or whatever. You may find like it may have 1 ohm or something like that. But if you measure the current flow through that light bulb after you illuminate it with 12 volts, and you can take the current flow and you can take the voltage, and you can calculate the resistance of that bulb while it's burning, and you're going to see like 4 or 5 ohms while it's burning, but only 1 ohm when it's not burning. Now the light bulb in that regard is a positive temperature coefficient device, meaning the hotter it gets, the more resistance it has. Spark plug wires are like that. Any kind of wire is that way. But negative temperature coefficient thermistors are designed to get less resistance the higher the temperature. Now, you know, some of the these engine coolant temperature sensors, like on some of the GM cars, a lot of other Jeeps and stuff, will have a 2-stage set up in the engine controller, so that you'll actually see the voltage drop and drop and drop and drop. Then you'll see it shift gears and go up and start dropping again, you know, because they need that resolution. Which sensor or circuit is not checked continuously on an OBD2 system? That's going to be your oxygen sensor heaters. Certain conditions have got to be met for that to be checked. Now, the continuous monitor are these signals that can be watched all the time, and they're basically supposed to remain within a range. But just like a lot of the other stuff, like for example, there's all your continuous monitor circuits, or circuits that basically are either fall within a range or either on or off or something like that. The ones that have to have, where criteria have to be met before they can be tested, like your evaporative system, your catalytic converters, your fuel system monitor, and your oxygen sensor heaters. Certain conditions have to be met before those things can be checked. So these are not continuously checked. They're only checked whenever the conditions are met. Conventional oxygen sensors don't work till they reach 600 degrees. The air-fuel ratio, you know, the wideband sensors, they got to reach 1400 degrees, the ones that I know about, before they'll start to work. The ones with the pump cell in them and all that. Which of the following would not be considered a computer input? TP sensor, magnetic pulse generator, park neutral switch. It's the EGR event solenoid. That solenoid is an output. It's not an input. Alright, all engines have some kind of PCV system, even diesels. They've all got some kind of positive crankcase ventilation. There's no such thing as a heated hydrocarbon vent. I just had some fun with that. But not all engines have EGR, and not all engines have an air injection reactor. But every engine has got a PCV system of some kind. Even back in the days before they had PCV valves in the 50s, they basically had a little pipe coming out of the block that was cut at an angle, so when you drove down the road it would create low pressure and draw that pressure out of the crankcase while you're driving down the road. Now granted, that, you know, was a pollution issue, and that's one of the reasons they came up with PCV. And positive crankcase ventilation makes the engine run a lot cleaner, processes that stuff in its mix and all. Now I will tell you this, if you've got PCV situation, some PCVs, we talked about this before, they've just got a little orifice for the PCV. Even some of your Chevrolet V8s have got that built into the valve cover, or they'll have something that looks like a PCV valve, but it's just got a little tiny hole drilled in it. But other than that, nothing's moving inside of it. It's got a hole in it. But if I found out years ago, after mass airflow came out, that you can put the wrong PCV valve on an engine and cause fuel trims to go crazy and throw codes because you put the wrong PCV valve because it's flowing too much air. And there's a calibration thing going on there with that mass airflow with that particular engine. Lean air fuel mixture burns hot and fast. Basically, you know, the leaner it is, the hotter it burns, you know, on that. And one of the things that the Bendix systems that Jeeps had from 87 to 1990. They had that bulletproof engine controller, you know, that was up under above the gas pedal. Those things actually had a titanium oxygen sensor that rather than actually measuring oxygen in the exhaust, they would infer how much oxygen is in the exhaust by measuring the temperature of the exhaust stream. And 5 volts was lean, and you know, when the closer you got to 5 volts, the leaner it was. It's the opposite of what you'd expect. The bottom would be, lower voltage would be rich, higher voltage would be lean, because a rich exhaust is cool, which would lower the resistance of the titanium sensor. And believe it or not, I think some of the Thunderbirds originally came out with some titanium sensors on them, and it didn't work very well, and so they had us replace those things in a short order because it was a big problem. One of the things I thought was strange was whenever Explorer came out with that 4-liter single overhead cam in 1997, I kept seeing Explorers coming in that were missing on cylinder number 4 because of a bad spark plug. Now, we had to replace the spark plugs in all of those under it wasn't a recall, but it was a program, that was, a program expires with time or miles, but a recall is good forever. As a matter of fact, there's a certain number of recalls that have to be done when a car has been recalled. And when we had the Renault franchise, they had a recall on some of those to replace the heater core because the heater core would bust and spray hot water all over people's feet. And so they had to have a certain number of those recalls done in order to get out of trouble with the federal government. And so they were telling us at the dealership, because we had the Renault franchise and Jeep, back when it was Jeep Renault, and they were telling us to drag vehicles out of the junkyard and change the heater cores in them. And those heater cores were aggravating to change, but they were changing all of them because it was a recall, because it was a danger to the consumer. Anyway, hot and fast is how a lean air fuel mixture burns. A fuel pump on a vehicle can be heard for 2 seconds at key on. A fuel gauge shows a fuel tank, 8.9 amps. That means there's fuel in there, or there's something in there. It's pumping something. Now, ever so often, you may find a fuel pump that will have the windings that are partially shorted that'll be pulling more amps. But one of the things I used to like to do was take a little cheap meter that would read 10 amps, and I would unplug the fuel pump relay, and I would just go from the pin 30, where the power was, to the normally open terminal and let the current go to the fuel pump through that meter and to see how much. And I've actually seen some that were reading fuel in the, they'd read like they had 3/4 tank of fuel, and when you measure the current that was going to the pump, you'd see 1.5 amps, which means there's no gas in there, pump spinning dry. All right. The least likely is to be an empty fuel tank. You could have water in the fuel, you could have inoperative fuel injectors, you could have fuel foul plugs, but an empty fuel tank is not what you're going to be looking at there. All right, if the idle air control counts are 0, the engine may have a vacuum leak. Now, what happens when you got a vacuum leak, depending on where it is, on a fuel-injected engine, if it's really close to one of the cylinders, it'll skip. If it's up here somewhere in the plenum chamber area, it'll cause the engine to idle higher. Well, because it's idling higher, the engine controller is watching the speed, and if it's using idle air control instead of an electronic throttle body, which just about everybody now got an electronic throttle body, but if the idle air control feels no need to try to hit a target because the target's already being met because of the vacuum leak, it will basically run that thing all the way in and just hold it closed. Because it's actually, sometimes if it's in the dead band, which is where it doesn't need to adjust the idle speed, or if it's basically too high, the idle air control will go all the way in. Now this here is one of those kind that's got the little stepper motors. The Fords would actually increase the amperage to their idle speed control to pull it back against, pop it back against the spring. The engine running at 243. This is the thing, if it's running hot and you got clean coolant. Now the reason I said clean coolant, I ran into a Renault Medallion one time that didn't have all that many miles on it. It was running about 240 something degrees. And the only thing that was wrong with that Medallion was I needed to replace the coolant with a fresh mix of distilled water and antifreeze. After I did that, it cleared up. Because the first thing you need to do is kind of like when you're checking the battery on an electrical system. This friend of mine's got a Toyota Highlander over there, and the push button start. I went down by the courthouse with this guy, my friend of mine, his daughter-in-law was down there, and we had jumper cables hooked up to the truck and all that kind of stuff, and the battery looked kind of crappy. But I was measuring on my meter, and I was showing just under 12 volts. And but when you mash the button, it wouldn't spin the engine over. And so it was one of those things that I have seen other push-button start vehicles that when you push the button, it would act like it would if the battery was dead. It would go like that. But on that Toyota Highlander, and I think it was about a 2010 model or something, when you mash the button on that one, it would do nothing. The lights burned nice and bright, but all it took to fix that one was a battery, because the battery was, you know, and a lot of these electronics, if they see the voltage go too low to be viable, they'll actually disengage whatever it is they're supposed to do and throw you some kind of a code. Anyway, I was out there on the street with no scan tool and you know, by the courthouse trying to figure that one out, but it turned out all it needed was a battery. Anyway, a bad water pump, if your heater hoses are cool to the touch, but the engine's trying to overheat, the most likely cause is a bad water pump. Either it's a one of those plastic impellers that's spinning on the shaft, and I've seen that, or it could be a cavitated pump, you know, reaction surface for the impeller, or the impeller itself can be rusted away. I've seen that before too. But I like to take those heater hoses loose, and I like to put a clear tube between them. You can buy that clear tube at ASE Hardware and stuff. Get some of the right size, you know, some adapters or whatever, and just put that in place of the heater core and crank it up and see what happens there. I mean, see if there's fluid passing through there, because it ought to go screaming through there, you know, whenever you crank it up, even if the thermostat's closed. It'll bypass through the heater core, and you ought to see it going through there. If there's not anything moving in that hose, or if it's got a bubble in it that's not going anywhere, you're basically looking at water pump issues. Technician A says the output of a Hall effect sensor can be checked with an AC voltmeter. You can't do that. Technician B says the output of a variable reluctance sensor can be tested with a lab scope. That's true. Technician B is the right one on that. What was the one thing OBD1 regulations required after 1988 that was not previously required? A dash-mounted warning light. Now, Jeep got away with not putting a dash-mounted warning light in there for, heck, it must have been, I think until 91. It was the first time they had anything that would be like a dash-mounted warning light. Now, those Jeeps did have this funky little timer thing. It had little gears in it like a little clock. And whenever it got to a certain amount of time, that the vehicle, it would, you know, let this little wire jump over inside and close the circuit. It would turn on what did that light say? It said maintenance required light in there. And what was funny was you were supposed to replace that little box. Sometimes that little box would rattle when you're going over bumps because the gears bouncing around it for aggravating. But you could peel a little sticker back on those boxes, and there's a little way you could go under your pocket screwdriver and reset that thing where it would turn that off. On some of the Broncos and stuff, they would have a maintenance required light. It would pop up. Broncos and F-150s, and they had a little sensor in there that basically would count the time that the truck had been running, and you would have to go over there and you peel a little sticker off of that, and there was a little tiny button down in the bottom of that hole. You'd hold that button, switch the key on, hold it for about 3 or 4 or 5 seconds, and that light would go off, and it would be ready for another 60,000 miles. But they also had an inferred mileage sensor that did about the same thing as turning on that light, but the inferred mileage sensor would ground a circuit to the engine controller. And the engine controller, when that circuit was grounded to the engine controller, it would basically account for the age of the emission system, and it would change the amount of upstream air, and it would change the way the EGR was working, and that kind of thing. Now, when that inferred mileage sensor closed, it would seem to me like when those vehicles would hit about 60,000 miles, and I never actually disconnected one of these, but I wondered about it. People would come in complaining about fuel economy issues with those pickup trucks and those Broncos when they hit about 60,000 miles, and I wondered for years, because we wouldn't find anything wrong with them, but their mileage would go to pot. And I wondered if it was because of that inferred mileage sensor input to the engine controller, you know, that was causing it to do something to foul up the mileage. I don't know. EGR system failure can cause any of the above: higher combustion chamber temperatures, pinion detonation, higher NOx emissions, or any of that. Now, gasoline direct injection engines can actually do this little, they can cool the combustion if it's pinging rather than retarding the timing. What they'll do is actually spray some fuel during the intake stroke. So you got fuel and air coming in there together before the spark plug fires, and that has a cooling effect. And then they spray again during the combustion stroke. And that pretty much cools everything down, but it helps emissions and efficiency at the same time, which is pretty cool. A technician has been led by DTCs to investigate the fuel trim. The crankcase oil may be contaminated with fuel. If it's subtracting fuel, that means it's correcting for a rich condition, if you understand what I'm saying. Now, none of this other stuff, fuel filter restricted is not going to cause negative fuel trim, particularly long fuel trim. But you see this a lot. You'll see this one here either way plus or way minus if it's been running a while, and this will be on 0, because this is going to correct to the point to where this one can stay close to 0. The fuel pressure low, that wouldn't do that, because that would have a plus right here instead of a minus and all that. Technician A says a bad radiator pressure cap can cause rust and corrosion and to build up in a car's cooling system. If you've got a radiator cap that will just let air come and go, you know you're going to have oxidation in there. You're going to have rust and all that kind of thing. That's not the only thing that can cause it, but it contributes to it in a big way. And this one right here, the large pipe, or the one without the restrictor in it, is going to basically be the heater core's outlet pipe, not the inlet. So you know, if you'll either have a small one or you'll have a little restrictor in there, like I showed you on a previous video. The inlet is going to be the small one, or the restricted one. The outlet. Why? Because that if you got restriction here and you got coolant going in there, that's going to put pressure on the heater core. It's going to bust it. You can hook them things up backwards and cause problems for yourself. Identify the place on this cylinder pressure waveform where the exhaust valve is completely open. Now you could say E or F, because at this point the piston's coming up, the exhaust valve open, you got a mild rise in pressure right there. See, this is atmosphere right here. You got a mild rise in pressure while it's pushing the gas out of there. I mean, pushing the exhaust out of there. What's the most likely reason for the no start on these pits? Well, if you compare transmission oil temperature and engine coolant temperature on one that's been sitting all night, and IAT is reading 101, then that's where you need to go. If the actual temperature outside is in the 40s and your idle air control, intake air temperature is reading really high, you might remember the body shop Dodge I talked about that was wetting the spark plug because of that kind of thing. 5-cylinder engine has a firing event every how many degrees? Okay, 144 degrees. And how do you get that? 720, which is a full cycle, divided by 5, which is how many cylinders you got, equals 144. If it's a V6, it's 120. If it's a 4-cylinder, it's 180. If it's a V8, it's 45. That ain't 45. I'm sorry, it's 90. A V8 will be half of this. A V6 will be that. 45 is not. That's not a good number for anything right there. I lied about that. So sorry about that, boo-boo. The temperature stamped on the copper case of a thermostat's wax pellet is the temperature at which the thermostat starts to open. On my Jeep one time, I noticed that suddenly, I like for an engine, these modern engines, to run up around 200 degrees. If they get much cooler than 200 degrees, you're going to start getting, PO 128 codes and stuff like that. Or if it's running cold enough, you'll get a PO 125. But I had my Jeep and it was running down around 160. And, the thermostat don't cost much. May as well go ahead and put one in there with a gasket. The problem is, when I was at a Ford place, one time over there, I had an issue like that with a cold running engine. I had to put 3 or 4 thermostats in it before I got one that would run warm. Anyway, on my Jeep, I says, well, I'm going to show these students this, and let them watch this happen. And so I put that thermostat in a can, and I put a torch under it, and I put a thermometer in it so we could tell what temperature it opened at. And it seemed to be perfectly okay. Opening in that can, it was opening just over 200 degrees or 195 or whatever it was. But I didn't put it back in the Jeep. I put a new thermostat in there, and it ran warmer, which was very strange. There was another time I was working on a Crown Victoria, and I had the a wireless interface hooked up to it, so on the computer screen I could look at PIDs, you know, in big yellow letters. And it was one that I was doing vehicle inspection on, and I noticed that that Crown Victoria engine was running at like 160 degrees after it was completely warm. And I said, well, that's not going to do. And I had a thermostat in stock for that thing, so I shut the engine down. And, you know, there was no pressure on the coolant system. I checked it first. And I just jerked the thermostat housing off. You know how easy it is on those older Crown Victorias to do that. And I dropped another thermostat in there. It was a new one. And put a new O-ring on it, put it back together, cranked it up. And within a minute and a half or 2 minutes, it had gone all the way up to normal operating temperature. I was astonished at how fast it corrected after I put a good thermostat in it. Technician A says exhaust gas recirculation is used to reburn some of the exhaust gas. I don't know how many times I've heard people say that. Technician B says EGR cools the combustion chamber to prevent NOx. Who is correct? Technician B. NOx is formed when the combustion chamber temperature goes over 2,500 degrees during combustion. You got oxygen in there, you got nitrogen. Whenever a combustion event happens, you're basically heating the nitrogen up, which is most of what that is, because it's 78% nitrogen, what's in there. Heats the nitrogen up really fast and it pushes the piston down. Well, whenever you get hot enough, you basically are locking oxygen and nitrogen together in all kind of compounds. You know, the reason it's NOx is that X can be any number. It can be, you know, 2, 3, 4, 5, whatever. And all of these different oxides of nitrogen, you know, they basically are split back, if it happens to make some, from the little hot pockets in there while it's burning. It gets rid of those by using the light-off converter, which is the one that's closest to the engine. And basically, in order to get rid of NOx, you have to have an absence of oxygen. But in order to take care of carbon monoxide and hydrocarbons, you have to have oxygen. And so sometimes oxygen's got to be added to the exhaust in between those two converters so that the rear converter can handle the hydrocarbons and the carbon monoxide by adding one more molecule of oxygen, or two if it's needed, if it's hydrocarbons. Anyway, that's another deal. Identify the point on this cylinder pressure waveform that most closely responds with valve overlap, which is when both the intake and the exhaust valves are both open at the same time. That's going to be right here, because the exhaust valve is closing here, the intake valve is opening, the piston's going down, the pressure drops to equal what it was here before the exhaust valve opened. And then, because, you know, piston's going down here, so piston's going up. Firing event, you know, compression, bam, it fires, piston's going down, the pressure drops, it comes up as the exhaust is being pushed out, and then it drops as air is being drawn in, and then it's on the compression stroke again. That's how that is. But this one right here, G, is what responds with that. If the vehicle speed signal has suddenly lost its road speed, I did not even put the answer, I didn't even highlight the answer on this one, all of the above. All of this, the speedometer needle will drop to 0, become dysfunctional, the speed control wheel, and the transmission drops back into first gear. I had a Taurus that did that one time. The sensor, you know, it would do crazy things, the speedometer would do stuff, and so I actually pulled a code and got a speed sensor code and had to get a speed sensor put in there. With the brakes locked and the engine in drive and accelerated to wide open throttle, what information might be gleaned from watching the stall speed on the tachometer? You're looking at the integrity of the stator one-way clutch. That's how you do that. Believe it or not, there's some charts you're supposed to fill out. And I used to connect the transducers and stuff on the SBDS machine, and it had a chart up there, and it had a range in which they were supposed, the pressures were supposed to be running in each gear, and it would tell me to drop it into, you know, these different gears. And reverse has got higher pressure than the forward speeds. Of course, you don't do it in neutral or park, you know, because you don't have the thing loaded anyway. But that's what you're looking for. If that stator one-way clutch is letting the stator spin both ways, you won't get torque multiplication, and it's going to lower your stall speed. Something else you can tell is basically if the engine's underpowered, or if the fuel filter's clogged up, or if the air filter's clogged up, you'll have low stall speed for that reason too. But if everything else is right and the engine's running like it's supposed to, you're going to find the integrity of your stator one-way clutch by doing a stall speed test on the ones that call for it. Now, be careful with this, because a lot of the newer automatic transmissions don't want you doing this test. But if you look in the book and you see that there's a stall speed spec listed, like one time we were working on the shop foreman's Expedition when I was at the Ford dealership. It was a brand new truck, and he had picked up an engine skip on one of the cop coils. And at the time we didn't have a good way to test for that because all that stuff was kind of new. And but I noticed that whenever we was stalling it, trying to get it to skip, we're there in the service bay, the stall speed was only like 1800 RPM. And if you looked up the stall speed in the shop manual, it was supposed to be 29 on that one, if I remember right. And I told him, I says, we found another problem. Your torque converter, your stator, the stator one-way clutch is bad in this thing, obviously, because the engine even when it wasn't skipping, the stall speed was a lot lower than it should have been. And so they put a torque converter in it and took care of that problem. But the skip had to be handled another way. But we discovered it by accident. A vehicle traveling down a straight highway, short and long fuel trims near zero. If a spark plug suddenly quits firing, the O2 is going to read lean and fuel trim goes positive. That's just what's going to happen. Why? Because that oxygen sensor is not smelling of fuel. It couldn't care less about fuel on the one, particularly the conventional ones are the ones I'm talking about. If it sees a bunch of oxygen, it's going to read that oxygen, even though all that fuel's blowing by there with it because it wasn't burned. Okay, so it goes by there, fuel trim goes positive. Now, we'll tell you this, as the fuel trim goes positive, it can screw things up, in other ways, and it can basically have the other ones running too rich and all that. But initially, it's going to see a lean, and the fuel trim's going to go positive. So none of these other ones are right on that, by the way. If you switch the ignition on and you hear the fuel pump, the PCM's awake and functioning. And that's one of the things I always taught my students. I said, if you're going out there to see about a no start, and you switch on the key, you ought to hear that fuel pump. If you don't hear the fuel pump, let me talk another little bit about GDI. GDI engines, believe it or not, gasoline direct injection, can have a vapor lock problem. And so what GM has done, and I don't know about the other automakers, they actually have it where sometimes when you've been sitting there for a while, sometimes these cars, when you open the door, it'll turn on the fuel pump, the low pressure fuel pump, to pressure the fuel system up. Some of the GM vehicle that you've been sitting there about 10 minutes, when maybe you're sitting there reading your newspaper and you get your key off and all that kind of stuff, playing with your phone, you may hear the fuel pump kick on and go, whee, to pressure up the fuel rail, keep it from vapor locking. With all that high pressure, you wouldn't figure it'd be a problem with vapor lock, but there's a problem there because there's just only a little bitty amount of fuel in that rail anyway as far as volume goes. Anyway, that's all I got for you today. I hope you really appreciated this because I enjoy telling these stories and talking to you guys. And if you leave me a comment or a like or whatever, if you want to, and I'll talk to you next time.